I believe we finished this page.
No, we did. The last two he left. He explained, but he didn't write.
Yeah, because especially with when we talk about the integers, really we're going to, if we graphed it, it's literally just going to be points because we don't graph in between them. And that I am not going to ask you to just graph a number line of just putting a whole bunch of points and dots because it's nothing. Integers are just our counting positive, negative numbers. So we don't have actually any numbers between them. So it's a little tedious and not very helpful to graph it. It's just a whole bunch of points. And the same is true with even numbers. So what we're going to look at next is this here. Now, what we call this is set builder notation. So it's comprised of three main parts. The first part, as we went over, the brace X is our number set. And if there's nothing given to us, it's just brace X bar. It's the set of all real numbers. X is a part of the real numbers. X is an element of the real numbers such that we describe it. We give what numbers we're actually talking about. So first part is like we're going to be talking about the whole number line, all real numbers. Specifically, numbers that satisfy this description. All numbers, all real numbers that are between 2 and 5, 2 is less than x is less than or equal to 5, make this true. So we will graph this, and that's really all it's asking us to do is to graph really the inequality. So 2 is less than x is less than or equal to 5. Now, because we do have two endpoints, that means we're going to need those two endpoints. We need 2 and 5. So we'll have both of those spots. Now we need to figure out if we need to shade or fill in either spot. If it's equal to it, we shade it in. If it's not, we leave it open. Is 2 included? Is it equal there? Do we have an equals line? Because it's just saying 2 is less than x. 2 is not less than or equal to it, because if it has the line underneath, it is equal. But because it does not, it means that a point at 2 is going to be open. Now, if we look at 5, because x is less than or equal to 5, since it is equal to it, we need to fill that point in. Questions on this here? And because it's bounded, it means that we need to shade all the points in the middle. I've referenced this the other day or the last few days. We can always check or pick a point and see if it works. If I wanted to say check 3, there's a point between the two. We can see is 2 less than 3 less than or equal to 5. Is this true? Yeah, 2 is less than 3. And 3 is indeed less than or equal to 5, yes? Since it's included, it makes the statement true. It should be included in the solution. So we would shade between these here. And doing this is very helpful on the ACT. Now, I would preface, because just make sure to check the other answer choices that number is not included in those also. But if any of the answer choices didn't include 3 as a part of the solution, we throw it out. Questions on how we did this here? You ready for the next one? For all real numbers, x is part of the real numbers, for all real numbers, such that x is less than or equal to 0 or x is greater than 4. This is a compound inequality because we have two statements. And luckily with our compound or inequalities, we can graph them independently because both of them are going to be included. So the first one we have is x is less than or equal to 0. So we know one of our points has to be at 0. Now, is it going to be filled in or left open? Filled in. It is equal to it. Now the question is, do we shade to the left or to the right? If you're not sure, let's pick a point to check. So what point can we check? -2. Is -2 less than or equal to 0? Yes, it is true, yes? So that means for this statement here, we would shade the side with -2. If it gave us a false statement, it was not true, we were going to shade away from it. We don't want that. Any questions on it before we look at x is greater than 4? Well, we know one of our points has to be 4, yes? Now the question is, do we shade to the left or to the right? To the right. If we're not sure, we could pick 5. Is 5 greater than 4? Yep. That's it. That's all it's asking. It's just asking us to graph it. Questions on B before we look at C? Sketch the graph of the set of numbers for all real numbers such that x is part of the real number such that x is less than -2 or x is greater than 0. First part's just telling us we're using the whole number line. X is less than -2. So we know we're going to have a point at -2, yes? Open or closed? Open. We don't have that equal line underneath it. So it's going to be open. Shade to the left or to the right? Left. I would agree. If we wanted to check, we could say -2000. That is indeed less than -2. Normally we wouldn't pick a number that big because we want to at least see it on the number line. But yeah, we're shading to the left. Or what? X is greater than. So we know we'll have 0 as one of our points, and we're going to shade to the right. Yep. That's it. Question on any one of these three here? Be ready for the next two. Now these are going to look, how we graph them is probably going to look closer to what you're going to turn in on your homework, because I'm not going to give you number or lines. It's just we do them. And when you do the number lines, first thing you'll want to do, especially if you have either one of these or just asking it to graph it on a number line, first thing we need is a number line, yes? Now I know some teachers that you've had before, the first thing we got to do is put our 0, so we know where 0 is at and go from there. I'm not going to make you put a 0 and space it out. Just what information is given? What are we actually trying to graph? Here, the set of all real numbers such that -6 is less than x is less than or equal to -2. It's a bounded interval, yes? So we have two main endpoints. One of them is -6, the other is. If it was unbounded and we only had one, how many points would we need on this graph? One. We just need that number. Because if it's like we didn't have that, it was just for all real numbers x such that x is less than or equal to 0, I just need the 0. Or if it was just the 10, I just need the 10. We don't have to put the 0, we don't have to put the rest of it. Just graph what it tells us. We put -6 and 2 because it gave us two endpoints, those 2 points. Is that going to make sense? Yeah. We can include more than it, but it's not actually giving us more information. -6, is it included? Yes, equal to it? Because if we look here, if we have the equal sign, then yes. But unfortunately, we don't. We just have the less than. So it's going to remain open. How about -2? Yes. We'll fill it in. Where are we shading? To the right of -6 and to the left of 2? -2? Yeah. because we can still do testing points like -7, 0, 1. -6 is less than -7 is less than or equal to -2. Well, this half is true. Unfortunately, this half is not. -6 is not less than -7, so it doesn't work. We can throw that point out. Same thing is true with 0. -6 is less than or equal to 0 is less than or equal to -2. Well, yes, -6 is indeed less than 0. But is 0 less than or equal to? But is 0 less than or equal to -2? Well, no, 0 is bigger than -2. So this point is thrown out. We can't have it. The only solution that works is in the middle of it. Does that kind of make sense how that check works? We ready for number 5? For all real numbers x, such that x is less than or equal to 0 or x is greater than or equal to 10, we have a compound inequality. We have two statements. We have x is less than or equal to 0. So I know one of the points on the number line has to be 0. And we have x is greater than or equal to 10, so we know the other one has to be 10. Now, with this one and the last one, the one thing I will say about doing the number line this way, we need to make sure the number line is set up correctly. Smaller numbers on the left, bigger numbers on the right. So we can't have 10 on the left and 0 on the right. We need it set up properly. Does that make sense? I can't have it listed as this, because that's just not how 0 and 10 fall on a number line. We have it flipped. Does that make sense? Okay. Zero, x is less than or equal to 0. Is it included or is it not? It is included, so we would fill that in. Would we shade to the left of 0 or to the right? Left, because we're saying less than, smaller. Then we can go to the other part. X is greater than or equal to 10. Filled in or open? Filled in, yes, because it is equal to. Shade to the right or to the left? To the right. That's it. Questions on this here? Probably been a minute since y'all done inequalities and graphing inequalities. Not too bad. Writing the set of number and set builder notation. So now we need to actually write it. Now there's two main parts of set builder notation. We have the description of our numbers and are describing our number types or what group of numbers we're talking about, and the description of what we're actually looking at, our description. Now for this here, our description is going to be this here, greater than 5. The type or group of numbers that we have, so this is our group of numbers, this is our description, if we have it in words. On the next one, we have that interval, that's our description. The interval is our description. However, we cannot write an interval in set builder. It really wants inequalities. If we're talking about a range of numbers, we need it in inequality form. So we can start from left to right. Brace. All sets start with a brace. Set builder. Sets. Brace. Now we need to describe the type of numbers. Well, it told us, yes? The set of all integers. If it was a set of all real numbers, it would be nice, because we can go what? Brace x bar, our line. Unfortunately, it's not. So what we do is like we had earlier, we're going to put this E. This E stands for element. X is an element of the integers. Z is what we represent our integers. You missed that. We went over that 2 days ago. So I will get that to you. We can get the notes to you. X is an element of the integer. So we're saying that x's contained in our integers are positive and negative counting numbers. So x is an element of the integer such that, so we described our group. Now we need to write this here, this description, greater than 5. Since we're talking about inequalities, and we've already set that our variable is x, we need it first. X is going to be what? Greater than 5. So greater than 5. We ready for the next piece? Right. That's it. So turning the set of all integers greater than 5. X is an element of the integer such that x is greater than 5. That's it. That's it in set builder. Questions on how we do this here? We ready for the next one? Now, as we look at this next one here, does it tell us the number set? No, but it actually does also. Because we're talking about an interval, we're talking about all the numbers from negative infinity to negative 1, or from negative 1 to infinity. We're talking about all of them. We're not excluding any, which means we're talking about the real numbers. All real numbers. If it gives us an interval to start with, or it gives us an inequality to start with and doesn't give us other descriptions, we're talking about the real numbers, all real numbers. Which for us is nice, because as we set up set builder, brace x bar, the set of all real numbers, such that now we need the description. And as nice as it would be to grab that and throw that in, we can't do that. We can't put in intervals in set builder notation. It would have been really nice if they gave it to us as an inequality, because if they did, we can throw it right in. Inequalities work. Set builder and set builder. Intervals do not. So we need to rewrite this as an inequality. 2 ways we can look at it. So the first statement, we're talking about the numbers from negative infinity to negative 1. We want all the numbers that are less than negative 1, yes? So we know negative 1 is our endpoint, and we know x is going to be less than it. If that negative 1 has a bracket, it's less than or equal to it. If it just has a parenthesis, it's just going to be less than. Okay? That's one way we can do this. The other way, almost there, is with this chart here. This chart here told us and gave us all possible unbounded intervals. And it told us that we have negative infinity, comma, negative 1. Which one of these 4 does it match up with? The 4th? Because negative infinity, comma, a. It's kind of the same setup, but instead of having a, we have what? Negative 1. So a, in this case, would be negative 1, yes? Which means this would be the same inequality, but instead of putting a, we're going to put negative 1. So x is less than negative 1. Because again, these 4 here describe all unbounded intervals. We just need to know what a is, because a is representing any real number. So we have that first part there, yes? Let's look at the second part. Negative 1 to infinity. So we're saying we want all the numbers that are greater than negative 1. It's not going to be equal to negative 1, because if it was, we would have a bracket next to that negative 1. So here we want x is greater than negative 1. If we looked back here, we could do a similar thing. Erase all that. Well, this time, It is very similar to the second one. But instead of having a, we have -1, so we're saying x is greater than -1. Questions on how we got either one of these statements? You ready to see how this goes into set builder? So we know that x has to be less than -1, yes? Or x is greater than -1. So really, once we get it in interval or in our inequality form, we just throw it into the description. That's the nice part, especially if it gave it to us as inequalities, we just throw it in. Questions on this here? I mean, yes, we could technically write this nicer, because if we look at this, we're saying that we want all the numbers that are smaller than -1 and all the numbers bigger than -1. What is the only number we don't have? -1. Set of all real numbers such that x is not equal to -1. Those are the same statement. Not too bad. Questions on this here? Let's look at number 6. -infinity, -1, or 1 to infinity. Well, let's go on and get our setup. Because they did not give us a number type, they gave us an interval, we're going brace x bar. The set of all real numbers, x. X is in the real numbers, x is an element of the real numbers such that we need our description. Now, funny enough, we pretty much did this one already, but that's if we look back at the chart. Very similar to the one we had previously, but instead of a parentheses, we have a bracket, yes? Which means we're not looking at the fourth one on the list, we're looking at the third one, because the bracket. That's the only difference between the third one and the fourth one on the list. Because of this bracket, we know that a is -1, which means here x is going to be less than or equal to -1. See the distinction between the two? It's very slight, but it's easy to get them mixed. So we know the first part of this is x is less than or equal to -1. Now, yes, we could have written it below it and then stuck it into the set builder, or we can just throw it right into the set builder. Less work. One to infinity. Which one would this match up to? Second one, parentheses a comma infinity parentheses. Tells us a is 1, so x is greater than . That's it. Questions on this one here? We're ready to look at number 7. We're not talking about real numbers anymore. We're talking about the integers. X is an element of the integers. X, E, and our Z with an extra line. X is an element of the integer such that our description, the set of all integers except -4. So we're saying X could be anything but -4. So what can X not equal? Not equal negative. Those are nice. It's saying it's everything, all our counting numbers, positive, negative counting numbers, except for -4. We don't include that one. So X is not equal to -4. Questions on this here? Questions on anything we've done so far? All right, let's look at the next one. So we want to write, so writing sets and set notation. The whole numbers 50 through 54. I'm going to probably need the other book. Yep. So is this writable? Can we just write this out? Oh, yes. Because what would be our whole numbers 50 through 54? Or what would the first one be? 50. Yeah. And what would the next one be? Yep. And then? Whole numbers are our counting numbers, our natural numbers and 0. This one's easy to write. There's no reason for us to go X is an element of the whole number such that 50 is less than or equal to X is less than or equal to 54. And writing it in set builder. Because we could easily list 50 through 54, just writing them out. There's no reason to go through the set builder notation. Questions on A? We ready for the next one? The real numbers 0 through 4. We kind of talked about this yesterday. It is not possible for us to write out 0 through 4. It wouldn't even be possible for us realistically to list all the real numbers 0 through 1. So if we're doing this here, we need it in set builder notation. Because we'd have our brace X bar. Now we need to convert 0 through 4 as an inequality. Now it does have 2 endpoints, which means it's a bounded interval. So our 2 endpoints, we'd have 0 and 4, and X would be in the middle, because we want all the numbers through 0 through 4. So we know 0 is going to be less than X is less than 4, yes? Now because of how they worded it, it's through, we do need it to be equal. 0 is less than X is less than or less than or equal to X is less than or equal to 4. Questions on this here? The integers 1,000, not 1,000, negative 100 through 100. Realistically, we can do this either way. Now, I wouldn't write out all the numbers for this because we would go brace, negative 100, negative 99, negative 98, negative 97. However, after the ... we can't just put a brace because does this continue forever? No, where are we going? 97, 98, 99. We can put an end on it. We just got to put the numbers in. Because the dot, dot, dot in the middle just says this pattern continues. Then we pick the pattern back up and say it stops here. Now, if we wanted to, we could write this in set builder. X is an element of the integer such that negative 100 is less than or equal to X is less than or equal to 100. Both of them work. This one here, it's neither here nor there. They're both about the same. To do either one of them. All right. Questions on any of this here? That is it for 1-1. 5 and 6, you can write it in set builder or as just a set. Both of those are easily writable. You can make the pattern and just use the dot, dot, dot to continue. 7 through 14, I believe, is just doing interval notation for all of those there. 17 through 20, I think, is graph. The given information, set builder or inequality or interval, you're just graphing them. And then 21 through 24, 26, and 27 is write it in set builder. That's it. All right.